Number 9, principal component analysis, PCA. So it's an unsupervised learning technique for dimensionality reduction. PCA transforms the data into a set of linearly uncorrelated variables. That's the principal components, while preserving as much variance as possible. So here you have sort of this field, and the analysis says here this is your one vector, and then orthogonal to it you get the second vector. So now you can describe the data, in this new dimension, no longer along here but along here. So you would sort of tilt it and to describe it, and these becomes the new component. These themselves are linear combination of the original components. So here just more details on this. So let's say you have correlated high dimensional data, and so this is where you want to take out unimportant information and just focus on the important one. And this is kind of the approach that you get here. Number 10, gradient boosting machine, GBMs, are extremely popular machine learning algorithm that has proven successful across many domains and is one of the leading methods for winning Kaggle competitions. Whereas random forests build an ensemble of deep independent trees, GBM builds an ensemble of shallow and weak trees successively. And with each tree, the whole system learns and improves upon the previous. So when combined, these many weak successive trees produce a powerful committee that votes on things, like in the other approach as well, that are often hard to beat with other algorithms. And so this is, the GBM is the approach, and popular implementation are GB boost, gradient, extreme gradient boost, light gradient boost, cat boost. Here's the illustration of that. Let's say you have a data set, you make a tree, you test it, you see your errors, you train it again, you test it, and at the end, you have better correct predictions, but you let your tree vote here along the way with different weights. That's your ensemble prediction. Neural networks, what basically was awarded the Nobel Prize in Physics in 2024, the foundations thereof, a class of algorithms modeled after the human brain, consisting of layers of interconnected neurons. Neural networks, or artificial neural networks, are highly flexible and used for both supervised and unsupervised tasks, especially for nonlinear problems. So example is analyzing EHR data to predict patient outcomes, likelihood of sepsis, development of ICU patients, and so on. And here's an illustration to explain that. Imagine you have a 30 by 30 grid, and you want to recognize the object, whether it's a circle, a square, or a triangle. So you have 900 pixels as inputs, and the system basically then combines these in successive fashion to identify what the right object is. And then these hidden layers, these layers in the middle that you don't see, they are able to recognize patterns. Because if you draw that circle somewhere, at a different spot, it's still a circle, but now these neurons fire differently, and these middle layers help to detect shapes and things like that.